Okay, 4-4. 4-4, graphs of sine and cosine. Graphs of sine and cosine. So let's start. We're just going to start with our basic parent functions. Okay? Our parent functions of sine and cosine. And then we're going to do a bunch of stuff to them. We're going to stretch them and shift them and reflect them and do all the fun stuff that we know how to do. All right, so here we go. Let's start with the graph of y equals the sine of x. Y equals the sine of x. Okay? And this is what we're going to do. We're going to take the numbers that we get on our unit circle and we're going to plot them on a graph. It's very exciting. So let me show you what I mean. Let's draw a little unit circle up here. Okay? And let's just draw it at 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. So this will be the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay? All right, and so and if I kept going around this thing, it's just going to happen again and again and again, the same points. So this is what we do. We go 1, 2, 3, 4. And at the end of that, we're going to put 2 pi. So we're going to start here. This is 0 at the origin, and we're going to go 0 to 2 pi. So in the middle of this is pi. In the middle of 0 and pi is pi over 2. And in the middle of that is 3 pi over 2. So each of those tick marks represents each 90 degrees that we're at all the way around the circle. So if I evaluate the sine of 0, the sine of 0, now for sine, I'm looking at all of the y values. Do you agree? So what is the sine of 0? It's 0. Okay? And then what is the sine of pi over 2? Go to pi over 2. It's 1. What's the sine of pi? We're back at 0. And then what's the sine at 3 pi over 2? Negative 1. Good. And then the sine of 2 pi, we're back to 0. Okay? And then don't draw jaggedy edges. Sine's nice and curvy. And it goes like this. And it keeps going. Okay? And draw arrows to show that it's going to keep going. That's pretty, right? Isn't this so pretty? Yes. So let's talk about these points. Okay. Do you see how this right here, 0 to pi over 2, this is like quadrant 1, 0 to pi over 2. And see how all my values are positive, my y values? And then look at the next one, pi over 2 to pi. This is like quadrant 2. And isn't sine still positive in quadrant 2? See all those y values? The sine of x equals a positive value. And then if you go over here, that's quadrant 3, pi to 3 pi over 2. And then the last one, did I run out of colors? I did. The last one is quadrant 4. And it's still negative. So it's positive, 0, and then negative 0. And that's what it should be. Fun, huh? Good times? If you were to take half of the way from 0 to pi over 2, do you know what that number would be? It's rad 2 over 2. Right? All right. And then if we were to go to our calculator, and if you were to plot y equals the sine of x, let's hit graph. All those points are on there also. Keeps on going forever and ever. If I hit trace and I plug in 0, I get 0. If I plug in pi over 2, I get 1. You see it's 1, y equals 1. If I plug in pi, I'm back to 0. Okay? Cool, huh? And then if I'm going to do cosine, which I'm going to show you in just a minute, and I graph cosine, cosine looks like the exact same graph, just shifted. And if you notice, see where they intersect right there? If I hit trace and I plug in pi over 4, shouldn't they be equal there? They are. 0.707, which is rad 2 over 2. They're the same exact point there. Cool, huh? Isn't that fun? All right, so that's your parent function. Now let's do our parent function for cosine. Y equals cosine of x. And remember, it does keep going forever and ever and ever. It does the same curve all the way throughout the whole domain. Oh, we didn't speak about domain. I'll do that on Tuesday. All right, here we go. So cosine, we're going to have the same tick marks. 1, 2, 3, 4. And at the end of 4, I'm going to write 2 pi. Pi is half of that. In the middle is pi over 2 and 3 pi over 2. And then let's say we're going to go up to 1 and down to negative 1. We always stay between negative 1 and 1 for our parent functions. All right, and then if we were going to go around the unit circle, we're looking at the x values now. Okay, the x values up here. And so if I go to evaluate what's the cosine of 0, what is the cosine of 0? It's 1. So I start up here. Sine at 0 is at the origin. Cosine is up at 1. And then I go up here to pi over 2. And what's the cosine of pi over 2? It's 0. It's the x value at pi over 2. Cosine of pi is negative 1. Cosine of 3 pi over 2 is back to 0. And then the cosine of 2 pi is up here at 1 where we started from. Okay? And so cosine graph looks like this. And this is your parent function. All right? And then let's talk about the quadrants on this one. This, of course, is quadrant 1 right here. And our cosine values are positive. Quadrant 2 is this right here. And our cosine values, as you can see, they're negative there. And then we get to quadrant 3, which is this area, still negative. And then we end at quadrant 4. And at quadrant 4, our cosine values are back to being positive, which they should be because all saints trust Christ. Yay! So that's the unit circle all plotted on a graph for you. So what are we going to do with these? Well, we're going to talk about their cycles and their amplitude and all this stuff, okay? So here we go. We're going to learn a couple of things. One is the amplitude. The amplitude of sine and cosine. Now, sine and cosine are the only ones that have an amplitude. And it's it's how high it is above and below the axis, the symmetrical axis, I guess you call it. How high it is above the symmetrical axis. Okay? So for sine and cosine's parent values, it's just 1. So the amplitude for the parent functions is equal to 1. And by the way, amplitude is always positive. No matter if you go to -5, that's okay. Still, it's kind of like height. You know, I could dig a hole, but I'm still 5 feet deep. It's still 5 feet, okay? So it's positive. All right, the other thing that we're going to talk about is the period. The period is how long does it take to go through an entire unit circle, an entire cycle of it. The period for your basic sine and cosine parent functions is always 2 pi. That should make sense because you go all the way around the unit circle and then you're back to starting over again for sine and cosine, okay? All right, now we are going to take these things and we're going to change them. Oh, no, I'll talk about that in a minute. We're going to change some things. We're going to change the amplitude and we're going to change the period. And so when you change the amplitude and the period, here's what happens. You have y equals a times the sine of bx. Okay, or cosine of bx, it doesn't matter. The number out front, the absolute value of that number is the amplitude. Okay, so if I put a 4 out front, that means the amplitude is 4, and what that means is instead of it going to 1, it's going to go to 4 and -4. Okay, it's going to bounce. I'll show you a graph of that really quickly on here, just so you can see it. So I have y equals sine x, and let's say I have y equals 4 sine of x. Let's see what that looks like. So it's going to graph the first one in blue, and the second one it's going to graph in red. And as you can see, it just takes those peaks and it really elongates them, right? And stretches them way out. It still has the same zeros, but instead of 1, I'm up here at 4. Instead of -1, I'm down here at -4. Okay, the other thing that's going to change is this b. This b is going to affect your graph. It's going to affect the period of the graph. So 2 pi divided by b is going to be the period. I'm going to show you how to graph something like that. Let me show you on your calculator what it does, though, just so you have an idea. So let me change this to the sine of 2x. The sine of 2x. So I'm putting a number in front of x. What happens is your basic graph is, just normal. 0 to 2 pi is 1 period. What this does is this makes a bunch of them. And so it shrinks it so that the period is now just pi, so it all happens inside of pi instead of all of it happening in 2 pi. And I'll show you how to graph those, okay? All right, so let's just do those first two things. Let's do the amplitude and period change, and then the last part we'll do our shifts. So here we go. Finally, we're getting to our first example, number 1. All right, let's go ahead and let's graph y equals 3 sine x. Okay, we're going to start off very easy. Y equals 3 sine x. So this is how I do this, okay? I say the amplitude is 3. Did the period change? No. Period's 2 pi over 1, which is just 2 pi. So the amplitude's 3 and the period's 2 pi. So I don't really change my graph. You know what I do? I change my scales on my x and y axis. So here's what I do. I go 1, 2, 3, 4. At the 4th tick mark, I put whatever the period is there. In this case, it's 2 pi. And then halfway between, I put pi. Okay, I need you to label your axes pretty good, and then the other way too. 1, 2, 3, 4. This is -2 pi, and this is negative pi here. All right, and then the amplitude is going to go up to 3. So I'm going to mark that 1, 2, 3, and then 1, 2, -3. All right? And now we're ready to graph. Once you have your x and y axes, your scales drawn in, let's go ahead and graph this thing. Okay, so I use basic sine. Sine goes through the origin. So I start by plotting a point there. And if you see, there's 1, 2, 3, 4 tick marks. So the next tick mark over, I'm going to be up here at +3. Then I go to the next tick mark over, I'm back to 0. It's almost like connect the dots. Like you start here, you go up, you go back. Now we're going to go down to -3 on the next tick mark, and then back to 0. And that's how you graph sine. Okay, and so you want to draw this like this. I think the book asks you to do 2 periods of each graph. I require 1. Okay, 1 full period is all I need to know that you know how to graph this. They want you to keep going like this one. You're down here at -3, and then you're back at 0, and then you're up here. Like they need you to do that. I don't. I'm okay with just that. Okay, and that's how you would graph it. All right, but you do need to know your parent functions, though, okay? So let's switch up and let's go to cosine now. Let's do y equals -4 cosine of 2x. All right, now I've done it. I've changed a few things. 1, I put a negative out front, and that's going to screw you up. 4 is our amplitude, and then I put a 2 in front of the x. Don't shake your head at me, James. It's okay. No. All right, here we go. So first of all, if I ask you what the amplitude is, please tell me it's 4, not -4. Okay? The amplitude is 4. And what's the period going to be? Period is 2 pi over 2. So 2 pi over b. I know, you got to memorize that. Yeah, it's 2 pi, the normal period, but then you divide it by b. And so the period this time is pi. All right, so let me show you how you graph this. Like I said, we're not going to really change the graphs more than we change the scale. So for me, I would go like this. 1, 2, 3, 4, and I would put pi on the end instead of 2 pi now. That way my 4 tick marks are all going to be the same still. And then in the middle is half of pi, which is pi over 2. So if you notice, everything's been shrunk down to 0 to pi as our 1 period instead of 0 to 2 pi. Okay, so then I have to do the amplitude, 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so now we have to think about what this negative is going to do. The negative is going to make everything flip over the x-axis. Remember a negative out front? Like if I told you to graph a negative x squared, you would flip it down, okay? So the negative is a reflect over the x-axis. X-axis. And so with cosine, my cosine, see, sine is always origin. I always think of sine starts at 0, 0. Cosine, I start by plotting my point at 1, 0. But in this case, I'm going to start, does anybody know? I'm going to start at -4. That point right there, that first point that you plot is so important. The rest of them kind of fall in, okay? So I started at -4 because cosine normally starts at 1. The amplitude changes it to 4, and the negative reflects it down to -4. All right, so this one I plot. My next one I'm at 0, and it's just going to bounce between -4 and 0 and +4 and 0. And then my next tick mark, I'm up here at +4. I'm back to 0, and then I'm down here at -4. And then here's what my cosine graph would look like. There we go. 1 full period of it. Okay, it does keep going forever and ever in both directions, but that's 1 full period of it. All right, let's do one more of these before we move on. Number 3. Let's do y equals -1/2 sine of x over 2. Y equals -1/2 sine of x over 2. Okay. So a couple of things. First of all, the amplitude is now 1/2. The amplitude is 1/2. Okay? The period is 2 pi divided by b. What's b in this case? It's 1/2. 0.5, 1/2. It is. B is not 2. B was 2 on the last problem because it was 2x. This is 1/2 times x. So what's the period going to be? 4 pi. Perfect. Take that bottom fraction, flip it up. The period is 4 pi, which means it's all being stretched. Instead of it doing the one thing in 2 pi, it's now going to do the one thing in 4 pi instead. Bless you. I mean, stay home. No, I'm just kidding. All right, here we go. So let's do it. Draw a graph. I've taught this different ways, like some years, and I just go back to this because if you see what the period is and you count 1, 2, 3, 4, and you write 4 pi, everything else is going to be easy. Okay, you write whatever the period is on the 4th tick mark, and then halfway through is 2 pi. Okay, and so then this is going to be 1 and -1, but I need 1/2 and -1/2 for my amplitude. So it's going to be shortened. It's not going to go all the way up to 1. It's not going to go all the way down to -1. And now we're ready. We're ready to graph. Okay, so what function is this? This is the sine wave. Sine, I love sine because I just remember it just starts with the origin. I'm not worried about is it up here at 1 or -1, whatever. Now, my next tick mark over is when for sine I usually go up to 1. Where am I going to go now? Yes, -1/2. It reflects that point over the x-axis to -1/2. Then I'm back to 0. And then I'm up at +1/2, and then I'm back to 0. Just flip-flops every time. And so what you get is this graph that looks like this. Maybe a little bit better than that, but it's pretty good. Yeah? Oh, because of this 1/2 out front. Yeah. So a normal sine graph, it doesn't say it, but there's a 1 out front, which means it's going to go up to 1 and down to 1. But if I make it 1/2 out front, all the y's get shrunk down to 1/2 instead of 1. Just like that, this last one had a -4, so it went up to 4 and down to 4. So this one only goes to 1/2 up and down. Yeah?
Is that where the negative would go?
What negative?
It goes from 0 to negative 1/2. So would it go up to 1 again or no?
It would go to 1/2.
Okay.
Yeah, so I start at 0. My first tick mark, I'm down here at negative 1/2, back to 0, up to positive 1/2, back to 0.
Okay, I was just wondering on the negative because you went from 0 back down. And I was just like,
The negative side.
yeah.
Where at?
On the left side.
Did I do it wrong?
You didn't mark it.
Oh, I did that part wrong. You're right.
I was just wondering
No,
if it was
yeah.
reflected
You know what?
or something.
I know I looked at that and something felt wrong. No, that's wrong. Thank you. And I would mark that wrong on someone's paper, even though I was the one that was wrong here. Yeah, you're right. It would go like that. Thank you. Yes, I appreciate that. Okay, so let's go on to part B now. We're doing okay. We're going to do some shifts. Okay, we're going to shift left and right and up and down. So here's how a shift works. If you have y equals a, let's do sine. I like sine better. Sine of b x minus h plus k. Okay. That's a lot. That's hard to look at. That's like, whoa, what'd you just do, right? Okay, so we know the a and the b part already. A is the amplitude. It affects the stretch, how far up and how far down. B is the period. The new things here are h and k. And they're exactly the way they are in a normal like graph that we've done with our parent functions. H is going to be a horizontal shift of right or left in the opposite direction. Opposite direction. Okay? Then K is going to be a shift of up or down in the same direction. Just like if I were to give you, you know, like a graph you're familiar with. If I told you to graph x minus 1 squared plus 3, you would take a parabola and you would shift it 1 to the right and 3 up and graph it, right? I would hope so. Like, sure. No, you go 1 to the right, 3 up, and there it is, the basic graph of a parabola. So we're going to take our parent function and we're going to shift it up and down and left and right and all that good stuff, okay? So here we go. What are we on? Number 4. Number 4. Let's do, I don't know, let's take our time on it. Let's do it in parts. Y equals 3 plus 5 sine of x. 3 plus 5 sine of x. Now they'll write it like this. This is why I wrote it like this. This is the same thing as 5 of sine x and then plus 3. You probably prefer the second way of writing it because you can see that you're taking this graph and you're shifting it up 3. When they put it in the front, it's the same thing. It's just they put it up front. Okay, so let's decide, let's see what this means. Here we go. You're going to need a graph. Did the period change at all? No, the period only changes if there's a number next to x, okay? So my period on this graph is still 2 pi. So I'm going to go 1, oops, don't do that. Go 1, 2, 3, 4, and I'm going to label that 2 pi. Now, here's the thing about shifts. This is the way I like to do them. This is going to be a shift of up 3. So I'm going to take this, and I'm going to go 1, 2, 3. Okay? My amplitude from the 3 is going to be up 5 and down 5. From the 3, not from 0, not from the x-axis, from the 3. So I'm going to count up 5. 1, 2, 3, 4, 5. I kind of ran out of room. So that makes me go up to 8. And then I'm going to count 1, 2, 3, 4, 5 down here at -2. Okay? So I also draw this pretend little line here because that helps me think that that's the x-axis. That's going to be really helpful. Okay? I kind of pretend like that's the x-axis now. And so when I start with sine, I want to be right here. Okay? If you don't like that, here's the other way to think of it. Where does sine normally start? Where do we start? At the origin. But I have to shift it up 3. So I'm up here. this is not a point on my graph anymore, I've shifted up 3. But instead of like taking all the points and shifting them up 3, I think of that as my new origin, my new x-axis. Yeah? -2. Oh, man. I've made so many mistakes today. That's -4, which we don't need. Thank you. Did I count too many? 1, 2, 3, 4, 5. Okay. Thank you. I need to go home. Okay, here we go. Let's go ahead. We have this point. That's our first starting point. That's important. Our next tick mark, we're going to be up 5 from that point. So we're right here at 8. Our next tick mark, we're back to 0. And I call it 0 even though it's not 0, right? It's my new 0. And then the next one, I'm down at the actual -2. And then I'm back to 0. And do you see how this thing is symmetric now over the line y = 3? Yeah. The funny thing is I've already done this once today. I shouldn't make any mistakes the second time around. There you go. Okay, now let's do a shift to the left or right. Last one, number 5. Let's take y equals 3 cosine of x plus pi over 2. Okay? 3 cosine x plus pi over 2. Now, I didn't combine a lot of stuff, like changing the period and shifting it and doing all the stuff. It's a lot. So we're just going to do an amplitude change and a shift. The period did not change again. So let's go ahead and we're going to graph. Use your scale. So the period's 2 pi. So we're going to go 1, 2, 3, 4. And that's 2 pi. This is pi. I'm going to write these in because these are going to be important to us. And also over here, -pi over 2. And then let's draw on our amplitude too. So go 3 up and 3 down. So 1, 2, 3, 1, 2, 3. 3, -3. Okay, now we're going to graph our basic cosine graph, starting at 3 instead, but we're going to shift that point, pi over 2, to the left. So this point that normally should be right here, well, it should be at 1, but now it's amplituded up to 3. I don't think that's a word. We're going to shift it to there, and that's our new starting point. Okay? And here are our tick marks. This is our first tick mark, second one's on the axis, this one, and then that one. And that one we're going to need too. All right, so the next one will be down at 0. The next one over, we're at -3. Then we're back to 0, and then we're up here at +3. So everything got shifted to the left, and so your graph should look like that. Hopefully the shifts are nice. Sometimes they're not, and they're a bunch of jerks to you. I like to shift things either pi over 2 or pi over 4, not pi over 3. Shifting pi over 3 is terrible, but we'll get to that. Okay, so you're going to get to practice some of these.